wave power. The average energy in the wave power in northern Atlantic Ocean is about 10 kilojoule per meter square. So as and when you please note down this. So first point itself is very important, and it's a multiple choice question over here. Average energy in the wave power in northern Atlantic Ocean is about, that is the correct answer is 10 kilojoules per meter square. So here it is accumulated wind energy to a height of 200 meters. On a medium scale, the characteristics of this creation and dissipation mechanism may make the wave energy more a constant source of energy than wind energy. So the variation in the wind and the wave energy are expected to follow each other. The seasonal variation in the wave power in United Kingdom, the annual capacity factor is around 28%. But it varies almost 50% in January and 10% in the February and in July. The average power density of this wave is estimated to be about 5 to 10 kilowatt per meter. On Swedish west coast, this is estimated to 20 to 80. And the utilization of this power installation would be 3000 to 4000 hours per year for Sweden, and 4000 to 5000 year per Norway. The global potential for a wave power is estimated to be 200 to 5000 gigawatt, the most of which would be offshore installation. The potential for shoreline installation is a factor of 100 less. The upper value of estimation would be assuming that 2500 hours per utilization per year, which will result in 12,500 terawatts of energy, electricity energy, being produced from the wave power, which would be over 60% of global electricity consumption in 2007. The lower estimated would, however, only be able to cover the 2.5% of consumption for Europe Atlantic coast. States a potential of almost 600 terawatts of energy per year, which would be 25% of again electricity consumption. So in wave power, we have the current status. We have seen some current status. As a global potential of wave power, which is of the offshore installations here, the potential for shoreline installation would be less than this 100%. Upper value of estimation would be from 2500 hours of utilization per year. These are some current generation status. So here many competing technologies under development, which is going on to harness this wave power and to convert it into an electricity, but none of them has come forward in with any prototype or installations which may connect to the grid in our future. Until now there has been any such issues has been came across. So the energy in the waves varies from 5 kilowatt per meter during summer, and which may go up to 1000 kilowatt per meter during winter storm. So it is a plan for several pilot installations that has to be carried out in our next coming generations, has been planned, and it's been going on. However, here a 2 megawatt installation on a Portuguese coast was taken out of operation after being connected to the grid for 1 year. So for 1 year here the wave generators has been serving the requirement of this electricity, which is of capacity 2 megawatt, which has been servicing for 1 year. That installations has been removed due to some issues. A pilot installation with 400 to 500 turbines and total rated power of some 10 megawatt is planned in Smigon and Swedish coast. So another an important an exam point of view or an internal point of view, an important question that comes out here is there is a pilot installation of 400 to 500 turbine with a total power capacity of 10 megawatts, where it has been planned to implement. The answer is Mogan on the Swedish coast. Here you can see that a pilot installation with 400 to 500 turbine and a total rated power of 10 megawatt is planned to install at. So this is the one of the important MCQ arising from this topic. The power generated with a 10 to 50 kilowatt are that are locally at the sea bottom. The park consists of many such units, the total which has a total power of 10 megawatts. Here the generator will produce power from pulses whenever the wave pass above the generator. So here the pulses are produced whenever the wave pass over the generator. That energy will be immediately converted into an electrical energy. So the larger park, the small, whenever there is a larger park, we need a small storage. So plan for a 250 megawatt wave power using turbine was carried out, and also 500 kilowatt have been presented for this Ireland. So compared to tidal power production, wave power is less predictable. So it is a major drawback in this type of generation. So however more constant, however at a more constant time scale of hours, so it is available at more locations than the tidal. So wave power is abundantly available in almost every oceans. No need to worry, but not in such a case of tidal power. Here the many cities and towns are located near to the coast, so offshore installation could be feed directly serve the purpose for local distribution grid, thus reducing the loading of transmission grid. Somewhat we can reduce that loading up of transmission grid by utilizing such type of generation. So it remains unclear whether wave power will look like as seen from the power system. So near shore installation may feed the distribution systems of some towns and villages which are located very near to that coast. Such installation may be a rather small installation, or some of the pilot project has to be lifted by our youths, so that many computing technology may come in our future, so that we can harness some this potential energy from sea, and we make use since from very my childhood this topic has been discussed, wave power, wave energy conversion techniques, but none of them has been came forward or taken place under sea. Using again we have to use here HVDC link for this installation. A few tens of kilometers, if they are located in that ocean, then again we need to go for this underground cable, which may cost even more. So the total capital cost may increase. Here the transmission cost will be more than the installation cost. So such major consideration has to be considered before installation or before harnessing the wave energy. So here the maximum one constraint is that the production capacity. Production in the sense it is dependent on this installation cost. So if one is ready to invest on this, then he must double invest on this transmission cable. So and he must wait for this long term. This is a long term investment to get back. So we are depleting as day by day we are ending up our fossil fuels. You can see in the various newspaper increase in the fossil fuel rate as the day progresses. Now we are at 99 rupees or almost 100 rupees per liter of a petrol that is we are using for transmitting of our energy. So the same amount of energy if we utilize for this capital cost of investment, then we may generate some sufficient energy. In future we may see that all electrical vehicles or two-wheelers will be of electrical vehicles. We will be less concentrated on this fossil fuel. So thereby if one invests and discovered such an alternating types of energy where we could produce our electricity, so thereby we can avoid pollution as well as the fossil fuel dependency on other countries. So this is about the wave power. So current status of wave power. So one important MCQ we have discussed, that is a pilot installation of 400 to 500 turbine and total rated capacity of 100 megawatt planned in Dash. So where it has been planned, it is Swedish west coast, world's biggest wave park. So moving on. So in this picture you can see that these are the coastal installation. These are the coastal installation of this generator where there's a difference between high level and low level. So that movement is converted into our electrical energy. So this is lifted generator, tidal. This is wave generator. Some of very recent technologies. So you might have seen. Okay. Next, moving on, we move on to this geothermal power. So this power is cost free, energy free. Only thing it takes place is the capital cost of the power plant. Geothermal energy is the most exploited energy, renewable energy source with more than 6,000 megawatt of installed generation capacity, and it has been installed in 21 different countries. So geothermal energy is one of the safest energy we can utilize. Geothermal energy extract heat from the earth's surface. In the figure you can see a red bottom line where the two pipes are connected. So here it utilizes the heat. Whenever the water is sent to this pipe, it will come back as a steam. So both you can see here in the picture, that is geothermal energy extracting a heat from the earth crust. So after that through an aquifer or water injected, so which will flows through that hot rocks or dry rocks. So energy conversion can be either mechanical means or direct heat can be utilized for the generation as well. Mechanical in the sense the steam, the passed steam will be sent to that to hit the horizontal generators. So here horizontal generators are placed. So this steam will be made to hit that horizontal generators, or that steam can be further sent to the processing, and it may generate by using other means. Okay. The main country uses the geothermal power for a larger part of energy production. Here is Iceland. So I mark this as a red. Another an important MCQ question for our internals as well. The main country which uses the geothermal power for a larger part of its energy production means here the geothermal is contributing more part of electricity production from the geothermal. So that country is nothing but Iceland. So geothermal provide 66% of country's electricity, mainly in the form of space heating. Also, hydropower provide 15%. About 500 megawatt of electricity is produced in geothermal plants. The untapped potential is said to be high as 50 terawatt hour, which is more than sufficient to provide the whole country, but only small part of global energy consumption here, which is about 20,000 terawatt in 2007. Here an overview of installed geothermal power plant of the global as total grown from 3,900 megawatt in 1980 to 9,000 megawatt. So in 1995 of the production, which is of 35%, was in United States and 24% in the Philippines. Enormous amount of energy are present in the core of our earth, but only to a limited number of locations. So this energy can be utilized. So there are many resources. For example, in northern side there is the coal. Northern part of our India, we are abundant in coal, but in southern we cannot find it. So similarly, in around the world, around the globe also, this energy is very limited in number of location. Extensively, this I think Iceland is very lucky to find this energy resource, so they are making use of it. At this location, the steam is produced in the natural way. That steam can be easily used the production of some electricity. Here, the production from the geothermal plant has been dropped significantly from time to time, because geothermal heat is used faster than it recovers at the center of the earth. So recover rate is less. That is why there has been some drop we can see in this production of geothermal plants in producing electricity to our consumers. The studies have been done towards the feasibility and directly using the hot magma deep underground. So I think it is not possible as well, because handling that hot magma is very difficult process and very high capital cost process, and it may leads to some environmental variation, impact on our environmental, and also human habitat will be gone. So it is better to be stay away from that magma. A study is done in 2005 concluded that whole of USA energy production could be covered for at least 5,000 years by drilling a hole as deep as 15 kilometers throughout the country. So here they have estimated that 2000 in 2005, so the whole USL energy can be produced by covering this. They can be utilized this geothermal energy for their energy production for 500 years, but it is again a failed situation. They cannot find this. Even they go for 15 kilometers deep, then they are not able to finding this geothermal power, because they are very limited in resource. And assuming that geothermal energy will be utilized in larger power in large scale, which is far from certain. It will be remote areas, again requiring enforcement for the transmission system. So again here the biggest constraint is also a transmission system has to be considered, because the as in our previous session we have discussed, generation and harnessing of electricity is very easy, but the transmission criteria conditions has to be satisfied. So our generated and harnessed or generated energy reaching the customer without any disturbances or qualityless or it should be a qualitative delivery should reach our customers. So this is about current status of geothermal power. So in this session we have discussed two important means of generation, that is one is wave power. Wave power, we have seen some recent development and the wave power and current trends, and what are the implementation around the world, and studies, research has been carried out in the world to harness this wave power into electrical energy. And also we have seen one important question at the starting of the session itself, that is average energy in the wave in Northern Atlantic Ocean is about at 10 kilojoules per meter square. After this we have studied this larger where is the largest wave park situated, and in the picture what you are seeing is that wave power generators, where the pulses are converted. Here the number of pulses will be converted into electrical energy and the different technologies that are not implemented, but they are still trying to harness it. So, and also we have seen one important thing, previously an wave power is generating some 1 megawatt of capacity. It is generating some power and it has been served 1 year for the grid, and later it has been removed. So after that we studied this status of geothermal power. So major part of this geothermal is present in the Iceland. So it's a very inconveniential situation that where the top of the land is covered with ice and bottom of your land is filled with heat. So an rare situation. So a very lucky country, Iceland, uses this geothermal power. It is a cost free and also environmental free, no pollution free, environmental friendly, eco-friendly. Then we have seen some advancement research in this geothermal power. So plans to implement this geothermal power.